Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this particular video, we're going to take a quick look at summation notation and its connection with sequences and series, if you will. So let's go ahead and get started. So imagine here that we have the following set of numbers. We got 2, 4, 6, 8, 10, and of course it goes on forever because it's a sequence, it's a series. Now when you look at this, you can quickly tell, or maybe you can't, that to the pattern for this particular series of numbers or this sequence here is going to be, we're going to call it 2 multiplied by k for now. So, and this is for, again, we're only going to do it for k is going to be 1. K is going to equal 1 to 5, 1 to 5. So we're not worried about infinity right now. We're just going to deal with these first 5 terms. So it's going to be k 1 to 5, and to get these first 5 numbers, you just take the k value and multiply it by 2. So to give you the shorthand, or the long version of this, is that when I have a sub 1 is going to equal 2 times 1, and that's how I get my 2. When I have a sub 2 is going to be 2 times 2. That's going to give me 4. A sub 3. I hope you're seeing the pattern. 2 times 3 is going to give me 6. A sub 4. When I have 2 times 4 is going to give me 8. And when I have a sub 5, it's going to be 2 times 5. It's going to give me 10. So that's my series right there. Now, what I want to know is, what is the sum? In other words, if I add up these first 5 terms, what is the answer for this? Again, I'm not worried about all of them. I'm worried about a partial sum, or the nth partial sum of the series. In other words, I want to know a piece of this series or sequence that goes on, forever and ever. And so if I only want to know about the first 5 terms, how can I do that? Well, we can, of course, calculate the long way like this: 10 plus 8 plus 6 plus 4 plus 2, and this will give us 30 for those of you at home. That's one way to do it, but there's also a slightly different way to look at this, and there's a way to try to capture all of this information here without having to write it out longhand like this, and I'll show you this right here off to the side. So another way to deal with this before we figure out how to get the sum is to use something called summation notation or sigma notation. And basically, and I'm really bad at drawing my Greek letters here, it's kind of like this, and it goes down, 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 then it goes up like that. It's kind of, I know it's ugly, trust me. This is a sigma. This is from the Greek alphabet. It's an ugly sigma, but trust me, that's what it is. And so how this works here is that you put something at the bottom called your lower limit. This is going to be our k. And so our k is going to start at 1. And then above the sigma at the top, you put your upper limit. That's going to be a 5. So what this means is that we're going to calculate the sum for the first 5 terms right here, as we've already talked about, and we already did it by longhand. Now, the one more thing that we need is that we need to have the actual explicit formula. And that's going to be right here off to the right, kind of in the middle of the sigma here, and that's going to be 2k. And so this is a shorthand notation for everything we wrote here off to the left right here. It's the same thing, except now it's condensed. Mathematicians are very efficient. They like to try to reduce and shrink things down to the most common thing possible, and this is a simplified version of what you just see here off to the left, and you're able to capture the same information. Now, the next thing I want to do is, we know that for our values here is 30. 2 plus 4 is 6. 6 plus 2 is 12. 12 plus 8 is 20, and 20 plus 10 is 30. We know what our answer is here, but we did that the long way. There's a more efficient way to do this, and it's a formula for finding the partial sum of a series. And so what it basically is going to be S of n. Again, now you're probably wondering, why am I using n? Because when we're talking about series and sequences, we use n. When we're talking about summation notation, we're using k. Sometimes they use n. It's very confusing, and so you have to be flexible. So you're doing S sub n equals n times a sub 1 plus a sub n, whatever that's going to be, all divided by 2. Okay, so we know what that is. Now, let's see here. Now, remember, when we're talking about n equals k in this particular situation. And so remember, our goal was that we wanted to find out what was the sum of the first 5 terms. So we're going to have a 5 there. So if I were to draw this here off to the right, it's going to be 5 here. And then let's see here. Now we know what our a sub 1 is. If we go back to our previous slide, our a sub 1 is 2 right here. And our a sub 5 is 10. Now you might have to calculate this by hand. You're usually going to have the initial term, but you might have to calculate the final term, the terminal term, I guess you can call it. So you might have to do this sometimes here at the bottom. But we already know them, 2 and 10. So we're going to go back. So a sub 1 is 2 plus a sub 5, because n is going to be replaced with a 5. And so we know that a sub 5 is going to equal 10 if we plug it into the formula, divided by 2 like so. So I think this is just basic math at this point, not a whole lot to talk about. 2 plus 10 is 12. 12 times 5 is 60. So we're going to have 60 over 2, or you can say we're going to have 30, which is the exact same answer that we just got. So this is kind of a taste of sigma notation, also called summation notation, and is going to be our friend. For those of you who have studied statistics, this is something you deal with a lot all the time. It's almost every other page has to do with some summation notation in the concept of statistics. And this is actually introduced here for many students in, like, pre-calculus and math, pre-calculus and calculus at this particular point. So let me kind of go back and summarize what we talked about and conclude this video. So in this video, we were introduced to finding the partial sum of a series. So you have a series of numbers. Okay, so we had 2, 4, 6, 8, 10. Of course, it goes on for infinity, but we only care about the first 5 terms. We know what our formula is, our explicit formula. And so we want to try to find out what is the sum of all these. And so we worked it out the long way here off to the left. And then I introduced you guys to sigma notation here, which is kind of a summary of what is happening here off to the left. And so when you understand this sigma notation, you can capture a lot of information that needs to be said in a very, very small amount of information. So basically what this is saying over here is that find the sum of 2k when k is 1 to 5. That's basically what that's saying. And instead of having to say that verbally or having to write that out in a paragraph, I can capture it in a handful of symbols. Rather brilliant are those mathematicians. And so here I showed you the shortcut formula for finding the sum of the partial sum of a series here. So you have your n times the quantity of a sub 1 plus a sub n, all that divided by 2. And not that complicated, just some basic math, but it's a different way of looking at things than what you have been exposed to in the past if you are new to math, this particular ideal in mathematics. So my name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.